All right, my pleasure to introduce our next speaker, Tom Henderson. He's a professor in the Department of Computing at the University of Utah in the USA. Take it away, Tom.
Thank you. It's the School of Computing, but okay. So I'm going to talk today about UAS traffic management, and I'm going to claim that I'm one of the automation talks here. So in robotics and automation, the idea is that you'd like to find some region like Salt Lake City. In Utah, they'd like to put large-scale flights over roads. So you go in and use a GIS system to find some road network. That's by the university here, the blue. And then what you want to do is build lane networks above it, where you can go up into those lanes and fly various places. And we've got an approach that we think does that with low complexity. So it's a lane-based approach. Here's the team. I will go quickly in the interest of time. So the problem basically is that there's poor old Salt Lake. There are going to be tons of these things supposedly flying around. This could be anywhere. FAA, NASA has a way to do this, but it requires pairwise deconfliction, which has a lot of problems in terms of complexity and privacy and other issues. So how do you manage all of that? And that's our question. How do you do safe, deconflicted flight with a simple approach? So here I'll show you one of our little simulations of a flight, a bunch of flights going through a lane network, where we give it a safety headway, never violated. You can run thousands of flights through this thing. The idea is that we simplify these networks in such a way as to make it computationally easy to schedule flights. They don't have to know about each other. They simply get scheduled into this thing by a reservation system. So that's our thesis. This lane-based approach makes life easy. Simple, straightforward, the algorithms become good, and it has a lot of collateral benefits. So one of these is that there's going to be an interaction between the UAS behaviors and such a UTM. It'll have policies like, what is this safety distance? That could vary between the platforms. So there's also, these platforms will have to have some cognition. They're autonomous. You can't have 10,000 of them flying around with people controlling them. So what would their brains be, and what do they have to do? How do they handle contingencies? So we've looked at these things, and we believe, in summary, this is the fake point where I say in conclusion and have 10 more slides. Basically, we've provided an efficient strategic deconfliction method, which is very cheap. We give analytical tools to look at these networks, to study them, see if they're any good, simulation tools, and a way for a bunch of community members to get together and put these systems together. So the idea is that, I won't go through this economics argument, we've done that for others, but that you'd have a system interface where users of various types, so planners, people just from the city or whatever, and everybody who's concerned, environmentalists and so forth, and the authorities, would get together and plan this thing out. They could simulate it and get back some feedback. Our view was in operational semantics, where you actually design a system, it simulates it for you, and tells you what would be some of the issues with it. So my student actually has developed, he's got a little company and does this kind of planning for places. He's done some for, the first one I showed you, the first slide was San Francisco simulation, and then he's been to Dubai and other places to do this. I won't go into the details of all of this because we don't have time, but just to tell you that there are a number of issues, and basically FAA, NASA has very hard problems they have to solve to run things their way. Our way is, I'll just say, simple. The basic idea here was that you make your graph such that every node has either one or less degree in degree or one or less degree out degree. This allows you a point-wise, you don't have crossing roads which you have to deconflict. So it makes it really a polynomial time, in fact quadratic, to do it in the number of flights that are in your lane sequence, which may not be many, so it's very low. You can have all kinds of networks. You don't have to be over roads like Utah wants. You could have grids, or you could have Delaunay triangulations, whatever you like. And we can do all of those. We can have multi-level or single-level types of networks. You can analyze these. There are a lot of tools for analyzing networks, but the visual displays will tell you, like, this is why a grid system, this exhibits something called gridlock. When you go through the middle, you can see that it gets very dense in terms of trying to schedule things through there. Our algorithm, won't talk much about it, but it basically has 130-something unique discrete cases based on how I want to deconflict with you. So it's very easy to have a lookup to go in and find out of all these cases where I can launch so that we are deconflicted. So I won't talk about the algorithm much. We compared NASA and ours, and of course we win. I won't go into the details of all that, but just to tell you, overview all this. And then this was Utah wanted these kinds of roads. That's why systems over roads, and they had various ideas. We conformed to that, but didn't have to do that. There's also a lot of infrastructure. So in the future, this means a lot of investment. I will forward reference to a panel on ethics later. Is this ethical? Should we be spending resources like putting upward-looking little radars, micro radars, equipping all of this with, RTK, GPS, whatever it is? A lot of expense to do this. Is it worth it to society? We'll have to think about that. So again, just to show you this stuff there, this method allows rogue detection pretty easily. If you're not in a lane, you're doing something wrong. So basically we can go in, and I got a picture here somewhere. Yeah, so there's various types of things we looked at, people trying to bug you or hobbyists and so forth. Lanes make that easy to figure out. Deconfliction. Well, you have lanes to deconflict with. So now I can use local stuff and not have a domino effect out to the whole network just because we can solve problems locally. We've looked at all of that. I've worked with some other people on where would I go land if I had to. And we can show that this method has very low cost in terms of failure, like we can't deconflict and I have to land. So it's got those things. Getting near the end here. So we were approached by the Air Force and did an Air Force STTR phase 2 to look at applications there. And here the notion was that if you have coalition forces, well, they don't want to tell each other all about their plans, but they just reserve slots in the system and they don't have to. So there's a lot of privacy involved. And you can do other things. For example, suppose that I'm in some region, maybe it's a little hostile or something, and I have high-level surveillance, I have manned flights, and I have UAV flights, and I schedule all of them using this algorithm. Well, it turns out you can do other things since you know where they're going to be, and they better be where they're going to be. Stuff can happen through the network. You can now plan things going through the network. So again, comes back to that ethics issue. So it's a good thing, a bad thing? Am I ethically neutral because I'm a scientist and I can get away with doing this and it doesn't matter how it's applied? Well, those are the issues. We have a book on this. We have some papers on this. 6:43, wow. Okay, we're almost there. So lately we started experimenting. This summer I was at the Air Force Academy and we did some test flights to see how you would have to calibrate the platforms to staying in a network. So we did some simple tests and then a dual flight test. So you can see here was our flight network and here's the path that was followed. Generally speaking, you can now calibrate your safety distance in terms of how reliable you want to be. 99% sure you won't have an accident if you follow this safety guideline, or you can double that and make it even better. So with 7-minute mark, I'll say questions.
Thank you, Tom. All right, let's do questions. Who's got a question for Tom?
But I'll be in the area upstairs, so we don't have to do that now because there's a last speaker that...
Question over here.
Oh, dear.
Yeah, you got a question.
Oh, man.
Yeah.
Peter.
You haven't worked hard enough.
Hello. So it seems that you propose to, instead of making the robot smarter, let's design our environment and maybe use an exhaustive database and then make planning easy. I guess I have a question and a half. One is, how often in the other talks where the speaker says, let's make a robot smarter, do you feel we should really be designing the environment? And then the other part of the question is, do you feel that we can do this environment design automatically? How often do you look into that?
So, I mean, basically, this is like a road network for UAVs. So it's not that hard to do, and it's really fast and easy. I mean, I go to the Air Force Academy, and within 30 minutes to an hour, we have a lane network and all of that. So then you just have to fly through it. You just schedule flights through it. So it's not a difficult infrastructure to put into place. As far as the intelligence on the UAV, it will require some because they do have to avoid running into each other. And so the question is, well, and we have a whole thing on that. So we use a belief, desire, intention architecture, and then pick ways to do things. So you can make that as complicated as you want to handle contingencies, which is where the real problem comes in. So I don't know if that answers your question, but I think the design side is actually pretty lightweight. The whole point is to keep it simple.
Do you have any other questions for Tom? Question up here.
Dr. Henderson, thank you. I'm curious about the communication required in the approach, if any, or if we're all operating on the initial beliefs.
Okay, so FAA is going to require telemetry data to be transmitted, and you have to be in contact. So as far as I know right now, there's no plan for these things to be flying quiet mode. So you'll be monitoring them, they'll be talking to you, and if they don't, then we have ways for them to fall back, and if they follow their plan, the idea is that they should be safe. So there are ways that they should be able to get through if they have problems, but then people would know that they're having a problem as well. So communication is just assumed that they will be following the standards.
Thank you.
He hasn't even got to 10 minutes yet. Can we do
Come
another
on.
question? Don't let him off the stage that easily.
Let my people go.
All right. I think
That's not
you're
even me.
free to go, Tom. Thank you.